Hello dear students, welcome to ECE Academy Benefactor. Class will be seeing conversion of SR flip-flop to T flip-flop. The topic is from sequential logic circuits and the subject name is digital electronics. So let us start the solution. What's the given problem? We need to convert SR to T flip-flop. Okay, so let us understand it first. SR to T we need to, so we need an SR flip-flop. This SR flip-flop is to be converted to T flip-flop. So first draw the SR flip-flop. Inputs are S, R, outputs are Qn, Qn bar. The clock pulse is negatively edge triggered pulse, so we have kept a bubble there. Okay, this is a given SR flip-flop. To convert it to T flip-flop, we need an excitation table. What this excitation table consists of 4 columns: input, present state, next state and flip-flop inputs. So what are the flip-flop inputs here now? What are the flip-flop inputs? S and R. So I write the flip-flop inputs as flip-flop inputs are S and R. Okay. What is the present state? Qn. What is the next state? Qn plus 1 is the next state. And what is the input? We need to convert SR to T. So what will be the input? T will be the input. Okay. So now let us fill this excitation table. For filling this excitation table, we will first write the binary combinations for the two input variables T and Qn. When we are having two binary variables, how many possible combination we can write? 4. They are 0, 0, 0, 1, 1, 0, 1, 1. Now we need to fill this next state. For filling this next state, we must know the truth table of T flip-flop. What is the truth table of T flip-flop? Whenever there is a change, the input are T and Q and 0, 0, there is no change. T means toggle. Toggle means whenever there is a change, output will become 1. So from 0 to 0, no change. So Qn plus 1 will be 0. 0 to 1, there is a change. So Qn plus 1 will be 1. From 1 to 0, 1 is changing to 0, there is a toggling, there is a change. So the Qn plus 1 will be 1. From 1 to 1, there is no change. So Qn plus 1 will be 0. So T flip-flop remembrance is very easy, the truth table, because whenever there is change, the output goes to 1. So let us fill this next state, the truth table of T flip-flop. So 0, 0, no change. So 0, 0, 1, 1, 1, 0, 1, 1, 1, no change. So it will be 0. Now we need to fill this flip-flop inputs. For filling this flip-flop inputs, we must know the excitation table of SR. So what is excitation table of SR flip-flop? Let us quickly rewind it. We will find, for excitation table we need Qn and Qn plus 1. When both are 0, 0, what is SR? It is 0x. When it is 0, 1, Qn plus 1 is 1, so it becomes 1, 1, 0. For 1, 0, it is 0, 1. For 1, 1, it is x 0. This is the excitation table. So to fill this excitation table, we must know the truth table as well as excitation table of SR flip-flop. What we are requiring? Truth table of T flip-flop. We need T truth table and we need SR excitation table for completing this table. Now let us see for 0, 0, SR will be 0x. For 1, 1, for 1, 1 it will be x 0. For 0, 1, that is Qn plus 1 is 1, so it will become 1, 0. 1, 0, Qn is plus 1 is 0, so it will become 0, 1. In this way we can complete the SR flip flop inputs. Now we need to solve the K map for S as well as for R. So this is a 2 variable K map between T and Qn, 0 1 0 1. Let us first fill for S. So what is X? 0 x 1 0, 0 x 1 0. Okay. So we are having only one grouping here. So what it is? It is 1, it is 0. So what it is? S is equal to 1 means T, 0 means Qn bar. So S is coming to be as T Qn bar. Now let us fill for R. It is x 0 0 1, x 0 0 1. So we can form only one group which is here. For this group, this is T and this is Qn. So R is coming to be as T Qn. So we got the equation for S as T Qn bar and R as T Qn. Okay, now let us draw the logic diagram. This is our logic diagram. We are given the SR flip flop. Now we are T is only one input. For S we need, what is S equation coming to be? S is equal to T Qn bar and R is equal to T Qn. So we need two AND gate, one at S, another at R. So let us put two AND gates here. Like this. Now to this both AND gates we can give one common T input. Where S is going? S is going to Qn bar. So as you are connecting here, darken this point. Now this R is going to Qn. Darken this point and connect to R in this way. So S is connected to T Qn bar and R is connected to T Qn. So in this way we can convert SR to T flip flop. For that what we require? We need the excitation table. Input, present state, next state, flip flop inputs. What are the flip flop inputs given? S and R. Present state is Qn, next state is Qn plus 1 and input is T. I hope you have understood the class. If you have any queries, you can post in the comment section. Thank you. Good luck, students.